So what I had to do to kind of make all of this possible was go to one or maybe two different interfaces away from this app and manually move 20 USDC from OP to scroll, then manually move 20 USDC from ARP to scroll, and then I have the 40 USDC that I can now spend on this app on chain B instead of chain B. This call it scroll, right? So this is the status quo, and the more fragmented my assets are, the more problematic it is. I have to go to more different interfaces, do individual bridge transactions before anything else can happen. Now, this is wholly problematic. So how do we kind of get past this, right? So how do you eliminate this manual process of bridging, essentially? So this is where Arcana comes in. So what we sort of put together as a design is we have the Arcana network, which is a Cosmos-based app chain, and its job is it's essentially like a state machine. It keeps the state of what we call user intents, and we'll talk a bit more about what those are. And what we also do is we have the Arcana vault contracts that we deploy on every chain that we support. And these are essentially escrow contracts. They hold funds on behalf of the user. So similarly, we'll have, the Arbitrum deployment, and also we'll have a Arcana vault contract on scroll like we do right now. So this is sort of like what we have, and beyond this, what we also have is what we will call as the Arcana solvers. So now what we do is, now if we go back to the original state where this user has 20, 20, and 0. Now, when the user needs to actually spend, let's say, whatever, this 40 USDC, we call that intention for the user to spend as basically an intent. And that is what the user submits to the Arcana network. And like I said, it's a state machine. So it records this intent and says the user is intending to use 20 USDC from their OP balance, 20 USDC from their Arbitrum balance to spend 40 USDC on an app on scroll. That is the intent. And that's when that intent gets logged in our state machine. And that's when things start to happen. Now, the state machine is responsible for basically orchestrating the rest of the flow. So the next step is for basically the first collection of 20 USDC to happen. And parallelly, it also does this other collection of 20 USDC onto Arbitrum from the user's wallet. Now, once these funds are escrowed on these two contracts, this basically sends out like a sort of, you could say, an event to the Arcana solvers. Now, the Arcana solvers are essentially liquidity providers. You can think of them as LPs who front liquidity on the destination chain based on the user's intent, so that the user can get the funds that they need without having to explicitly bridge their assets and wait for that bridge or switch context. Now, as soon as they receive this information that these funds have been escrowed, they now start to fill intent, which is basically send 40 USDC over here. And now this money basically just passes through and comes down into my wallet on the scroll side, and I am able to kind of go ahead and submit my transaction on this app on scroll. And all of this happens without me ever leaving this this interface that I'm on, everything just gets managed for me. I've just clicked just a couple of buttons to ensure that all of this just happens. It happens with my existing wallet. I don't have to like go anywhere, do anything. It's just a few button clicks, and basically all of this just happens in the background, and I'm able to go ahead and proceed to do whatever I intended to do on this app on Scroll. So this sort of intent solver architecture is what we employ to kind of make chain abstraction happen, where a user is coming, they have assets on any chain, but they're fundamentally being able to kind of spend that combined asset on any other chain that they want to without having to switch context. So that's what we make possible.
Awesome. Wow, this is so clear. You did a really good job. I think I have a few kind of like follow-up questions when it
Yeah.
comes to the details, right? What kind of implications does this have on, let's say, like gas cost, right? Because let's say in the original form, it would be like, okay, I have to pay the transaction fee to bridge for
Yeah.
OP, and then I have to bridge for ARB, and then I have to bridge and then like combine everything. Yeah. So,
Yeah. So yeah, fundamentally, what you would be doing is like originally is you would have to do bridge TX of arb to scroll, a bridge TX of OP to scroll, and both of these have gas costs, and these depend completely on the bridge implementation, where you'll be spending gas to call the bridge transaction, and then you're waiting for the bridge to kind of do its thing, and finally you end up with assets, and then you do this other thing, and these are separate transactions with their own gas. And so what we do now is, in the chain abstracted world, is there is a collection on OP, a collection on ARB, and a fill on scroll. Now, if you think about this, these are essentially like either basic ETH transfers, depending on what asset I want to kind of spend. In case of USDC, it's a standard, it's basically like a ERC20 transfer. So you would be paying probably lesser in terms of gas, because even this is just a transfer. And you would actually, it's actually more optimized. And the good part about all of this is, if I need this USDC and I need to submit this transaction on Scroll, I need even the gas token, which I may be missing. So what could additionally happen here is it sends me 0.0001 ETH for gas. And what I am going to be doing is I'm going to be sending 20.05 USDC. So in order for me to get the ETH on Scroll plus the 40 USDC that I want to spend, I can get that from my solver on the Scroll chain, but I pay in USDC the whatever is the gas cost that I have to incur for submitting this transaction, which would be whatever it is normally. But I don't even need to hold ETH on the destination chain for me to kind of make all of this happen. So that's sort of like how the gas situation is with chain abstraction, and the way we've implemented it at least.
okay, cool. I have follow-up questions, but we also have some questions in the chat. So I guess attendees take precedence over me. Nisha has a question. I think Cosmos has a 14-day lockup of some sorts. Would it apply here anywhere in the process?
No, not at all. So all this does is it's basically keeping track of the state machine, that is of the intent state, and that's all it's there for. If you see in any of this flow, actually as such, what happens is that we bring some of this data, like this collection data, on chain, like this fill data, we bring it on chain, but none of this comes in the way of the user getting the funds in order to transact. So what we've done is sort of delayed bringing all of that stuff on chain, but it really does not matter because this does not interact as such in a way which requires anyone to like sort of build their application with this in mind. This is completely abstracted away for the user. All they have to do is effectively just have the Arcana SDK sort of Arcana SDK. Sorry, just installed here, and that's it. There, you don't have to deploy a contract to our chain. There is no implication of any sort of like the staking on our chain or vesting on our chain on the app that is integrating our SDK to enable this for their users. So yeah, I hope that answers that.
Awesome. More follow-up questions, I guess, for someone who's building something very specific. Goal is to buy an NFT on Scroll for 30 USDC. Would this be one transaction on Cosmos that transfers 20 USD, 10, etc., that move to the minter on Scroll? And how does this impact allowance transactions on OP and ARB?
Yeah. So if you wanted to spend 40 USDC, you would obviously. So the way we do it is actually you're not transferring funds when it's an ERC20. You are not actually transferring the funds from your wallet. You've given these contracts allowances, and basically they're pulling the funds from your wallet based on whatever your intent was. So this collection essentially happens through a pull from your wallet based on the allowances that you've already set. These allowances can be set beforehand, where you basically give infinite allowance to these vaults, or they get set on the fly. Now, the thing with setting this on the fly is, of course, these are button clicks for the user. They have to worry about having gas on the chain and things like that. So if basically you do a one-time setup of the allowance for the user, then this can be collected. In the case of ETH and not USDC, this basically just is a direct transfer from your wallet that you initiate. And suppose this was whatever, 0.2 ETH and 0.2 ETH, you do two like send transactions from your wallet, and then the rest just happens. In fact, this exact same use case that you're talking about is what I will showcase in our workshop right now.
Oh, awesome. Well, okay, before we dive in the workshop, I have like a few more questions, if that's all right.
Yeah. Sure.
Cool. So in the bridge world, I guess going back to like one of the concerns about bridging, right, is obviously security. I'm wondering kind of what you guys do in terms of security protections, or if it's safer, right? Probably, I'm assuming it is because you're not doing so many bridging transactions on the Arcana side.
Yeah, so fundamentally, what you're doing in this entire flow, if you think about it, is you're moving risk away from the user all the way up to the solver. The solver is the one that is fronting this liquidity with the hopes that, essentially these funds are eventually settled back to it. So what we do is, because as the protocol and the service provider, essentially in this case, is the solvers are essentially sort of placing trust in these contracts, and the way the protocol is built out, and all of this, of course, open source, will be audited. Right now we're in testnet. Before going to mainnet, it will be audited. And the idea is that as soon as these sort of like deposits happen, the solver is now saying that, okay, so the user's funds are now locked in, they're escrowed. There's a resource lock placed on the user's funds, so the user cannot double spend them. And then consequently, they go ahead to proceed to fill my intent that of 40 USDC. On the user side, what happens is that if this collection were to happen, and if a solver does not fill, if no solver fills their intent, then these contracts essentially refund the money back to the wallet. And this happens like every 10 minutes or so, where we calculate any sort of refunds that are, any settlements that are pending, and we just settle them back if in case the fill for the user was not done. So the user will, in case of like a failed intent, there is an inconvenience. For the solver, basically, as long as these funds are collected and they go ahead and fill, and the Arcana state machine is saying that this particular solver filled this intent, then it will settle back whatever funds are due, with of course some fee that these solvers are owed for basically providing the service.
Cool. And then my final question is whether or not you guys also do like any sort of swaps, right? So let's assume I only have $20 worth of frog,
Mhm.
right? Is that part of it, or is the assumption here that I will have enough like USDC in my wallet to fund?
Yeah, so this is something that we are going to get to. So right
Mm-hmm.
now you have USDC on other chains, you spend USDC. You have ETH on other chains, you spend ETH. You have USDT on other chains, you spend USDT. So that's how we've structured it. But obviously, the idea is I have ETH, USDC, and USDT, but I want to spend Sol.
Right.
Right? That is the next step of evolution for the chain abstraction protocol, where we can actually make that happen. There are a couple of ways in which we can do this. One is obviously, like you intuitively guess, it's a swap to some sort of base asset, whereby my USDC, USDT, and ETH gets converted to some base asset, and then that base asset is what the solvers supply on the destination chain, but it goes through a swap to give me the SOL that I need to be actually go ahead and complete my intended transaction. So that is something that we are working on right now, and it'll be available in the near future.
Okay. Awesome. Hopefully also within 17 weeks. If not, that's fine. We're building for longevity here, so whenever it comes out, um, we'll keep an eye. So if there's no more questions, I mean, obviously, keep asking throughout the stream, but let's dive into the workshop and see how people can actually start using this right now.
Cool, yeah. Let me just see if I have everything set up here. Um, yeah, looks like we are good to go. I'll share my screen here again. Let me know once you can see it.
Okay, we are live. I can see it, but I imagine we probably need to zoom in a bit.
Yeah, we'll do that. Okay, so what we have here is a very simple NFT mint that we're going to be doing. I've already sort of like imported this code. There's a GitHub repository for this code base. I'll share that with you. Maybe you can share it with your audience and the community to basically try this out. So let's basically let's get this up and running, and we'll take a look at it over here. All right. So yeah, so what you can see here is a very simple, extremely basic NFT mint site. What it does is it shows you this NFT. It says the price to mint it is 0.0005 ETH, and this is on the Scroll blockchain. I've deployed the contract on the Scroll mainnet. It's a simple ERC721. And when I connect my wallet, what it shows me is my ETH balance on Scroll, and it basically says I have insufficient balance to be able to mint this. Now, if I head over and kind of check out this account here on DBank's sort of portfolio viewer, I have a lot more in assets that are spread out across different chains. On Scroll, like you saw, I had the 0.401 ETH, which is too less for me to do anything about. But if I head over to Arbitrum, I have more ETH here. I have more than what I need to mint that NFT. If I check OP, I have more, even more ETH. If I go to Ethereum, I have more. So basically, all of these chains that we support, I have I have enough to be able to kind of mint this, but I just don't have it on Scroll. So now what I would have to do is to head over to some sort of bridging interface and start to bridge assets over, perhaps from Arbitrum to Scroll, in order for me to have enough ETH to be able to kind of mint this NFT, right? But let's try and remove that sort of friction and try and get to a place where the user doesn't have to kind of do even ever leave this sort of interface at all. So the first thing we'll do here is basically I have some notes here that I'm just going to use to copy paste a bunch of different things. Step one is installing the Arcana Chain Abstraction SDK. I just go ahead and do that here. And once I have that, very soon, come on.
This is just internet.
Yep, almost there. Yes, there we go. All right, so we have Arcana Chain Abstraction SDK installed. So next, we just need to kind of create an instance of the chain abstraction element, basically in our app. So I'll head over to my utils that I have here. Wait, hold on. I think it was this. Yeah, okay. Okay. I just put this here. I obviously need to import this. There we go. And I need to just export this getCA instance. Go back here. Okay, so step one done. Now that we have this done, let's fix this also. There we go. Now, the next thing that we'll try and do is basically get and show the unified balance. So right now, what you see here is just my balance, ETH balance on Scroll. Can we show the unified balance to the user where it basically shows them all their ETH across all the different chains that we support? So let's head over to our use wallets hook. Oh, not this. Our wallet provider, no, wallet connect. Yeah. So we come down here and I need to basically initialize the chain abstraction first and foremost. And oops. Oh, let me just quickly find where that is. Okay. Okay, I must say that most of this stuff is, yeah, okay. This is not it. Abba. This is done. This is not it. Wallet connect. This ain't it either. Sorry, I'm a little stuck. I seem to have forgotten. It's I'm just such a horrible dev, and it's all thanks to the team here that uh, I've been able to kind of get this far. But
No worries, no worries. I mean, you will have, like, a complete GitHub repo with all of the correct code, so
yeah, I do.
it doesn't
I
feel
do. I
live,
have that as backup.
right? Yeah,
I
that's
have it as backup.
we're
Yeah.
real people.
I'm just going to jump to that so that you can see what's, yeah, there we go. So, um, first thing we've done is we obviously did the utils part where we set up the CA and we're exporting the get CA. We're going to get end up using that. Um, so yeah. So what we do is in this sort of like this hook for use wallets, what we are doing essentially is fetching the balance and we are showing it. So if you kind of compare what we have with what it should be, so right now I simply am getting the balance uh, from like from my window.ethereum, and I'm able to kind of just show it as it is. But what we want is to be able to show like the unified balance over here. So so if I go to my wallet, yeah, you see this here. This very standard ways in which I'm just using my ethers to be able to fetch the balances. But what we want is to be able to get this unified balance. So what all we need to do is to initialize this CA using the get CA instance. And once we've initialized it, all we have to just make this simple call to this SDK method, which says get unified balance. And I specify what asset I want to. I can specify an array of assets or for all the assets that we support. And once I have that up and running, basically we can convert our existing balance that we are showing to the user from just the scroll balance to this now unified balance that we have over here, right? So this is what, if I were to show you guys what that looks like on this other instance that I have running, and I connect my wallet here, it's going to ask me to sign in, simple CV signature. And now if you can see here, it shows me my unified ETH balance here for the same account for literally the same thing, but now it's spread across different chains. But again, this is chain abstraction. You don't even have to tell the user what chain they're on in a sense. And while here, I could not mint this asset because I had insufficient balance, I have more than enough balance here to be able to go ahead and mint it. So now the next thing that I need to be able to do is basically, once we're showing this sort of unified balance, next is to basically set up this check of whether I need to do chain abstraction or not in order to kind of proceed and take things forward. So if I go to my page here, it's just a single page site. So what we have here is this NFT minter function in which all we are doing is we are again sort of getting this CA instance from get CA, and sorry, hold on, it's here. Yeah. So all I need to do is, instead of when I use this sort of create wallet client to be able to write transactions using VM, I specify the chain and I say I'm using a custom provider, which is the Arcana CA, which we've instantiated here. And then all I need to do is just call my transaction, this write operation to this contract where I'm going to be doing the mint. And because it's using the custom provider, the SDK checks internally if you have the funds or not to be able to kind of call this mint function. But if you don't have, then all it's going to do is going to do the chain abstraction bits for the user, and then make sure that the user has the funds on the scroll chain, just like how I described it in my diagram there, and then consequently go ahead to submit this transaction. You have to change absolutely nothing in your code except for basically saying, instead of using window.ethereum, you're using the custom CA provider over here. That's basically all the change that you need to be able to do. Most of the change that you need to do is essentially UI stuff. Like, you want to be able to show the user the intent and for them to sign up on it. So you kind of need some React handling for that. You need to be able to kind of show that uh, intent in a dialog box, which we'll see very shortly. And it's just front end code that you need to write to be able to kind of handle this now multi-chain experience that you're giving to your users. So if you kind of try and see it in action, right? So what happens is when I hit, in fact, we can just open the console so people can see what's happening. I hit the mint button. What we're going to show this user is that, okay, so you want to spend 0.005 ETH on scroll. You have very little on scroll, but you have more on Arbitrum. And basically, for a fee, we can make all of this happen, right? And so for this total fee of 0.00002 ETH, which basically comes from my Arbitrum balance, I can go ahead and make this happen. So all I will do is say allow. And once that gets done, this is my initial signature off to our Cosmos chain, which basically creates the intent. You can see here it's created the intent. Now, once that is done, I'm going to sign off on the ETH transfer from my Arbitrum one. Again, I didn't have to click any buttons to change chain, nothing like that. My funds are going to get collected from my Arbitrum balance, go into the escrow contract, and once that is done, a solver will fund me the 0.005 ETH, basically the liquidity that I'm missing on the scroll side to be able to kind of make this happen. And then once I have it, I can go ahead and submit this transaction as well. So just hold on. Let me just try that again. Okay, initial creation of the intent, that'll get done. You present the user with, and there we go. I've basically submitted my assets on the Arbitrum side. I'll receive them on the scroll side. And as soon as that happens, I'll be able to do my final transaction here. I've got the ETH necessary to complete the mint. I go ahead and hit confirm. Now my NFT is going to get minted on scroll. I can see it happen. All gets done. So I basically clicked 3 buttons and I was able to use assets on different chains to be able to spend on scroll to be able to mint this NFT. And now if you go check it out, I've been minting a bunch, but you should be able to see it. Yeah, this is the oldest. This is the newest one, number 5, that just got minted over here. So yeah, this is what you can basically do with the Arcana Chain Abstraction SDK.
Awesome. Well, that was very simple, which is good.
Yeah.
Yeah. I actually do have another question that kind of popped up in my head was, do you guys do like priority for which chains you source
Yeah.
from?
Yeah. So we do actually, and it's let me just come back here. So right now we have an internal way of trying to figure out which chains do I have the user have funds on. Okay, so these are the chains. What is the gas price on each of these chains? And we sort of order that up and start taking assets from those chains in that order. But this is something that with newer versions of the SDK, we're going to change up, which will basically allow the user to be able to pick the chains, or rather exclude chains that they don't want the chain abstraction protocol to use. and then it'll just sort of readjust the fees and everything
Mm.
else. So all of this happens on the intent creation time. So you can adjust things, slide things up and down, exclude things, and then just hit confirm, and then it'll just do a bunch of things for you. So yeah, that's sort of like the idea.
Awesome. Yeah, I was gonna say, I was like, I wonder there's perverse incentives for chains to be more expensive so that you don't withdraw from them. But yeah, no, thank you so much. This is, like I mentioned, it was very easy. It was very clear. Feel free to send me the GitHub
Yeah.
link afterwards. I just wanted to say some, like, shout out some fun chats from the comment. Anonymous LinkedIn user, bullish on Arcana. Um, what is it? Impressive, so good, well explained. You feel the passion and genuineness of the host. It just pours out of them. Yeah, this workshop is a must for builders. Yeah, so I guess that's us bragging about ourselves. Last piece is, if we want to get connected, how do we, like, what is Arcana's Twitter, your website that I can just like plop in and flash on the screen?
Yeah, so our Twitter is at Arcana Network. DMs are open. You can always reach out. The multiple people who look at that account, so things filter through eventually for sure. Our website is arcana.network. There's some contact information there as well. So you can definitely reach out through various channels. We have a Telegram group. You can reach out to us there. But yeah, if you want to look up the docs, then it's just docs.arcana.network. You can just head over there. We have a cute little chat bot that'll help you find your way. But if they're not doing a good enough job, a human at Arcana is never far away. You can reach out to me. You can reach out to um, just our handles or any of our official sort of social sites, and we'll find you and we'll help you.
Oh, awesome. I guess also, if you're in our Scroll Builders chat, that's where I'm sitting, so you can bug me to bug
Yes.
Arcana. But that, don't abuse that privilege, or maybe do it. I don't know. But yes, last piece I wanted to say. Like I mentioned, hackathon is happening right now. If you guys didn't register, registrations are closed, but we are doing referral codes. So if you're still listening and you want to join Scroll Open, you can head to open.scroll.io. There's going to be an application. You'll have like either a referral code or referral email. You can go ahead and put Arcana, all caps, and that will allow you to still join in. But yeah, I guess I'm gonna count down from 5 to count for YouTube lag, and if there's nothing else, I'm gonna let you go, and say thank you for your time. So 5, 4, 3, 2, 1. Okay, well, again, thank you so much for coming. Arcana Network on Twitter, docs.arcana.network. Have a great day, and I'm gonna let you go. So, bye.